Hello, welcome to this tutorial video. Today in this video, we'll learn how to set up for binder sinter simulation within Altair Inspire. So let's say this is the part that I want to 3D print using binder sintering process. And you might be aware of that whenever we print the through binder sintering process, the size of the model get reduced because of the shrinkage, right? So we need to know how much do our part need to be scaled up so that uh, we can print that much part, the part with a scaled up version, so that in the end we get a part with the desired shape or form. So let's start. So within Inspire, it's quite easy. Just you need to click on the part, select the part, okay, and give the material for the part. So there are plenty of material in here. Although if you want, I want to add certain kind of material or different material properties, I can do it from here. So another thing is to define the initial temperature. Let us keep 300 Kelvin and move out of the tool. Next thing is to select an oven. So if I just click on the oven, it will give me a default or an X1 oven. So within X1 we have different kind of models that can be selected. But for now let's keep a default. In default also we can alter the X, Y and Z uh, axis or the dimensions within X and Y and Z direction. Let's create it. Okay, so our part is set now. Now we need to give the orientation. How are we going to print our part? If I just go into the orientation, it will ask me what do you want? Do you want maximum height or minimum height? Or do you want the base to be touching a certain kind of surface? Okay, so let's say for this kind of case, I'm good with the the orientation of my part, but I want to know where my part can develop sag. Okay, if I just click on sag preview, it will go ahead and quickly give us the results for from where the parts will bend a bit. So as you can see in here, the portion which is do not have any support has bended a bit. So if we just see the higher region, so these are the uh, surfaces or the portion of the scan model which will be having some problem of sag. So we can install some setters in here, or we just deform our body such a way that after shrinkage it takes uh, the shape that we desire the most. So let's move on to the setter. Currently we do not have a setter, so let's go and perform the simulation. If I just click on this play button, a dialog box will appear. It will give us all the parameters that we can vary. So currently, let's say we are going for shrinkage type of simulation. It will ask us if you want to scale up or scale down our model. As we know that the due to shrinkage, the actual model is quite scaled down. So we can scale up our model. We can give the temperature ranges of our oven. From in here, we can import an Excel file, or even we can change it from this graph as well. So this can also be done. So let's restore to default and close this. So I've run a simulation for you. So let's go back to that simulation and see. So this is the simulation that I have already ran. So this is the shrinkage. So as you can see, our original part was this one, and now after shrinkage the part has deformed this much. So if I just go into the volume change, the maximum volume change is about 36%. So just play this one. So it will show me how my part is going to deform with respect to time. So at some regions we need to scale up say 36%, right? So you need to do an trial and error thing to just figure out uh, the dimensions or the correct scaled up version that you need to scale. So what we have within Inspire is something called a compensation type of analysis. If I click on compensation type of analysis and if I run it, so it will give me the desired input shape for binder sinter process, so that in the end after shrinkage I get the shape as I desired. So if I just go into the results and if I just go into the compensation iteration 3 and just move this slide on the left. So this will be the shape that will be required. Now you can see, first thing, this is a scaled up version. Second thing, from the bottom it's a bit, bit out of the plane, so that after shrinkage it get aligned to the plane. We just play it. So you can see, after shrinkage it will take the desired shape that we in the end wanted. So it's quite helpful. We need not to go through the iteration. The system will do all the iteration and give us the result. Now once I have it, I can save this file as an STL. We just save as, let's save it in the desktop, STL file. And now if I just open my STL file in here, so you can see, if I see from the left, it's a scaled up version of our part. Now we need not to go through the iteration. The system go through the iteration and give us the desired part. That's all for this video. Thanks for watching.